I'll be using just 12 columns to carry this building you are seeing here on my screen. This building is a 6-story hotel building located in Cape Town, South Africa. Now, the reason of using just 12 columns to carry this structure is based on the design architects and also the clients. They don't want to have much columns on the structure because of the features the building has. In the course of that, that made me to have a decision of using 12 columns and positioning them on the critical points of the structure. So in this video, I'll be showing you how to locate critical points of a structure or of a building and then to place your vertical support members like columns and walls. Also, because of I'm using just 12 columns to carry this 6-story building, that made the length of beams will be at a minimum of 7 meters and above. In the course of that, this video will have more value for a particular stages of engineers, beginning from the intermediate engineer to senior engineers and to well higher experienced engineers. Now, by saying that, I am not scaring other engineers below these stages. For example, junior engineers and students. If you're a junior engineer, don't get angry because I will be breaking all the principles down that is involved in designing long span beams and also a structure of this kind. And if you're also a student, don't get it twisted because I will also be breaking it down to your own level for you to understand all the principles involved. So with this, we can now then begin the structural framing of this particular structure. Now, this is a real life project. As I said again, it is located in Cape Town, South Africa, which you will see the site plan and every other plans involved. Also, note that this particular structure which you're seeing here have a complete course video which we recorded beginning from the structural framing up to the modeling, design, analysis, and then performing interactive check on the members and then going for the foundation design, which we used a raft foundation for this particular 6-story building. Now, the reason of using the raft foundation is because of the properties of the soil the soil test and the bearing capacity. So it was a raft foundation that was suitable. So in this video, also in the course video, you will also learn the choices on how to choose the type of foundation for a particular structures. So if you want to get the course video, you can look at the link below this video description and then purchase the course video, or you go to our bio and go to our Ekidel online store and then you can see other courses and other materials which will enable you on your structural engineering career. If you also want to follow this video as we are designing, you can also purchase the CAD file following the link below this video description. So by knowing this, we can then begin right now. But we cannot begin if we don't support us by also recommending your friends and colleagues to also know what is happening here on Ekidel. Knowing that the mission of Ekidel is to train the younger engineers and to make knowledge as simple as it is in the area of civil or structural engineering. I have not been around for a very long time. For like a month now, I've not been around. I went on break and other things too. But right now, in this month of October, I am currently available and I welcome you all to the month of October. Yeah. So I would like you to do me a favor by liking this video and also sharing this video to your best friend that is also a civil or structural engineer. Now that you have liked the video and also shared to your friends, we can then begin what we have for today, which is the structural framing of this 6-story hotel building. And if you're from South Africa, know that Ekidel has come to your land. And I greet every citizens of Cape Town that is watching this video right now. We hear you, and then let's begin. Hello, welcome to Ekidel, where we train future civil and structural engineer. My name is Justice Umaka and I am your instructor. In this course video, I will be performing a 6-story hotel building using the software Protastructure. And this is a real-life project located in Cape Town, South Africa. So looking at this building right now, this is a 6-story hotel building, and you can see that we have all the sections, all the elevations that we need to perform this actual structural design. And also we also have all our floor plans. You can see that from the third floor to the sixth floor they are typical, and you can see the third floor building plan, and then we go onto the second floor building plan, and then the first floor building plan and the ground floor building plan, and this is the site plan. And then looking at this building also, we have a 2.2 meters cantilever, which you can see here on my screen. I'll always also be showing you the principle to perform this design for this 2-meter cantilever on this course video. So now, once you get your building plan, sorry for that, from the design architect or from the client for you to perform the structural design, the first thing to do is to study the architectural building plan. And when I mean by studying, I mean by you looking out for the features of the building plan. And what are the features of that building plan? First thing to look out for is what is the purpose of the structure. In this case, this is a hotel building. So what it means is that the purpose of this 6-story building, or for this building, is to be a hotel building after the construction. So the usage is for hotel. Now that you have known the usage of this particular building, the next feature we have to look out for is to look at the features or the components of the building, or that makes up the building. And what I mean by components, I mean by, is this building having a lift shaft? For example, a lift, elevator. Is it having a staircase, which of course is meant to have a staircase? What type of staircase, or what kind of staircase? Is it a concrete staircase, a steel staircase, or a timber staircase? Now, each of these things you are looking at for is to know what components that constitutes the structure. That will help you during your structural framing of that structure or of any structure. Now, in this case now, if you look at this is the ground plan and ground floor plan. Now note that no matter the number of stories you are designing for, always start your structural framing from where? From the ground plan or from the ground floor plan. Why? The reason is because every other stories are being generated from the ground floor plan. So the ground floor plan becomes the reference plan for every other stories. Now, even if now you might be thinking that, okay, it is because the ground floor plan is the first plan, or is the first plan of the whole structure or of the whole building. No, even if you have a basement which is below the ground floor plan, you will still begin your structural framing from the ground floor plan. So what it means is that you frame your structure from the ground floor plan and you transfer every other member either below or above, beginning from the ground floor plan. So the ground floor plan becomes the master plan for our structural framing. Okay, so knowing that now, we are then going to perform our structural framing following the ground floor plan. And when we are done with our framing and positioning our vertical members, which is the column and the reinforced wall, we will then copy those columns and populate them or superimpose them to other floor plans, which we will now look at how the column positions will behave on other floors. Because most times you might place a column at a particular point, and then on the other floors, since there's a cantilever or something, or that wall shifted, you will see that the wall or that column will now be appearing on an empty space, for example inside the bedroom of the first floor or third floor or fifth floor. So in that case, that will now guide you on how to arrange that column so that it will not be able to appear from an empty space on the other floors. And if at all you cannot arrange it very well, then you can, then when you get to that floor, you can terminate that. Now all the things I'm explaining, I would have been doing that when as we are proceeding for the structural framing. But now let me just cut that short, which I will see explain later. So in this case now, since we are using the software Protastructure for this particular design, and I'm using the 2026 Protastructure for this because of the components or the features this new version of Protastructure has. And when I mean by features, this is the 2026 Protastructure. I have done so many projects regarding this. Now note, this is a shared license, so everything is working. No, I've been hearing rumors that when you use 2026 version, you cannot be able to open a previous work that you have done. That's a lie. As you can see, I can be able to open this one I have just done now. You can see I've just opened it now, which is already open. So if you're using a shared license or a personal license of this software 2026, then you'll be able to open any other projects that you have done. But if you're using a cracked version, then you have issues that after modeling you won't be able to open the project you have done again. You can see that I am currently opening mine, which is still opening just now. So if you want a shared license of this version 2026, you can contact us, or you go and read about a shared license, about Protastructure shared license on Google, so you can be able to understand how the concept work. That is fine. So in this now, let's just open, then we'll now proceed to our structural framing. Okay, that is fine. I just came to want to show you that this is the software we will be using to perform the structural design of this 6-story hotel building. Okay, that is fine. So it's currently opening now, which is this is the building I did for a client in Abuja, some Chinese client that is coming to invest in Nigeria. So let me go to the 3D model. Yeah, Korea, this is it. It has a basement, and then it's, yeah, a basement, and then so this is 4 floors, and this is 3 floors around here. Okay, that is fine. So we will then go back to this now, which is our this. Okay, that's fine. So we are now on this particular 6-story building, and in this we will then begin the structural framing. That is the first place you're meant to start your structural design or analysis from, is from the framing. If the framing goes wrong, every other thing goes wrong on that structure, or you find it difficult to correct that mistake during your modeling. So make sure you spend time on your structural framing. So with that, let's now begin. So knowing that we are going to use Protastructure for this design, we are going to create 2 layers. The layers, we are going to call one column, and then we call one bin. So in that, I'll come now and type layer. I'm using 2026 AutoCAD, so I'll just type layer, and I'll press enter. So on this enter key now, we will now come here and then come and create 2 layers. Call one column and call one grid. So with that, I will then come now and then click on this place here, and I'll come and spell here grid. Make sure it's spelled correctly, and I want to choose my grid to be a red color for my grid, and I'll say okay. I will just skip all this line with it, that doesn't matter. I'll then come again here, click on this again, new layer, and then type column. Now on doing this now, we are setting the properties of our structural member. So I want to choose blue for this my column color. You can choose any color that you want. Then for the line width of the column line width, I want to choose line width 0.5. So I'll scroll down and then choose 0.5 for my line width, and I'll click on what okay, that is fine. And I'll come now and then click on what close. So with this is the only 2 layer the software requires you to use for your structural framing. Now you can also create beams and walls, which after when you import it, you will see your beams appearing, but that's in a complex way, which I will show you guys later. But in this, I want you guys to focus first on using the grid layer and the column layer in performing your structural framing. So with this now, we will then proceed. So you can see that this building plan came with grid lines, which I can choose to maintain them or create my own structural grid lines. Okay, that is fine. Now, I want to maintain these grid lines, which are here on the that came with the building plan. But if at all the building you're using didn't come with a grid line or axis, you can create your grid line at the midpoint of every vertical wall or at the midpoint of where you want to place your column. Remember, on this earlier stage, I said that this building, the client and the architect said that they don't want much column to appear or to be on the structure. So in that, I and the architect made or did a column arrangement during when we were creating these building plans. We did a column arrangement and then we agreed that this is the number of column we are going to use. I did a column arrangement for the architect and told him the points where the columns are going to be. I have to choose the critical point because they want few columns, in the sense that my beams now are going to have a longer span ranging from 7 meters to 10 meters and above. So in that case, I have to pick a critical point of the structure to place my vertical members, which is columns and a reinforced wall. So we are going to use only 12 numbers of column to carry this 6-story hotel building. Only 12 numbers of column and with a minimum size of 400 by 400 millimeter. So in that now, let's now begin to create our grid lines. So since this one came with a grid line, I will come now and then click on this and then come again here, click this, and then click this one here. By doing this now, I will then come here, click on this and choose grid line, grid, come here, make sure they are by layer, and this by layer, and this by layer. So with that now, I have now converted the existing grid lines to a grid line. Now, if I now press an escape key, you will see that the column, the grid lines, they are now in what? In grid line layer. So with this, we have then created our first grid lines or the grid lines for this ground floor. Now you can see that there was no grid line created around the lifts, knowing that lifts area are always a reinforced wall. So since they are reinforced wall, we will also create grid lines on the reinforced wall. So with that, I will have to divide this wall by 2 and then come here, divide this wall into 2 like this, and just to locate the midpoint of that wall. So I'll come now, press F8 to get my midpoint, and then this is the one I'm looking for, and I'll press XL, enter, H, enter. That is to do or to create a concentration line. And I'll come now and I'll delete on this, delete this, and then we then have this line now. I'll match property MA, match this to this, so I don't have this. So on this now, I'll then come now, XL, enter, V, enter for vertical, create my boundary line here, click on this, TR to trim off, and then trim off this, and then click on this again, XL to extend this extension line out, and again that's all. Then come now, delete this, E, enter, XL again, V, enter, and then come here and click on this. Now I want to remove these unnecessary grid lines that are found here. I'll come now and but before I remove that, always make sure you copy out your plan from the original one so that you're going to have a copy. All right, don't always work on the original building plan. So I'll come now and copy this out, all right, and keep this here. So with that now, I'm only working on this on this one here now. This is now our copied one. So again, I'll click on this now and then type T arrow and then trim this off and then take this off. So with that, I will remove all the unnecessary dimensions that I don't need here. This will go off, and then these also dimensions are also going to go off. That is fine. This also goes, that is fine. So with this now, we then come now, XL enter, V enter to create an what alignment between these grid lines, this extend and then this trim. Okay, that is fine. Then E enter. So with that now, we have then created our grid line for this lift. The next thing we do right now is to create a, so there are going to be also a grid line around this lift, because this whole place here is a lift, as you can see that, and this whole place too here is also a lift. So with that now, I'll press SL enter, V enter. Now to locate the center point of this, you're going to have an issue. So you have to do what? Divide it first using using a line from here to here, and then XL enter, V enter, and then click on this. Now if you are confused about what I'm doing right now, we have a free video on YouTube where we explained about structural framing from the basics. You can then go and watch our comprehensive video where we performed structural framing, where I explained every detail on how to perform your structural framing using grid to grid, and where to choose the best grid or the best wall to place your grid. So you can watch those videos on our YouTube. That is fine. So I came right now and then delete this, and then come my MA enter, and then come here, click on this, and then click on this. And again, I will then come now. This is also a lift wall because this is the lift entrance. That means that there should be a wall. So I'll come now, also do this here, and then type XL enter, V enter, click on this here, and then remove this, MA match property, and then click on this here, and then click on this here. That is fine. So with this now, we have now done this. Also create another one here too around this area from here to this point here, and then XL enter, H enter, then click on this, delete this, and then MA enter. Always delete the one you used to divide the wall, else they will appear as a grid line on the software when you export this. So again, we then come now, we also need a wall here. I also come now, let me see, we already have a wall here actually. So we are going to place this wall and then make the wall to align outward. So we are not going to place another grid line here for this purpose. Okay, that is fine. So again, we will then come again now, we need to create a grid line for this lift wall on this side. This is the two grid lines we need to create, and then we are done with the grid lines stage. XL enter, V enter, and then come here and then place this here and delete this, MA enter, match this property for grid from this to this here. Okay, that is fine. Again, come again now, L enter, that L simply means one line. Then come here and I'll click on this place here. Then XL enter, V enter, come here and then place this around here, delete this. Okay, MA enter, and then come now, click on this here, match this property to this one here. Now we have now done this now. Okay, now the next thing we'll do just now is we have three lifts on this building. We have one here, which is, you can see it here, one, and then we'll have 2 and 3. That's double lift here. That's 3 lifts we have on the structure. So this is also another feature that we have just discovered. Then we then have staircase around this place, and also now we have other steps. These are not staircase, but these are steps. So we are not going to design them structurally. This also is not a this is also a step, so but can be designed structurally. This should just be a mass concrete and having maybe a wire mesh, a mesh reinforcement. So these are not structural staircase, and you can see that we have a ramp here that will lead an entrance. These are not structurally designed ramp, so we can use a we can use a mass concrete to get this ramp by using our wire mesh for reinforcement. Also, we can also get, this is also a step to enter. So these are not structural members. We are only focusing on the structural members of this particular building. Okay, that is fine. So in that course now, we are then now going to there is no also need for us to place, let me see. Okay, there's need. Okay, I was thinking that we are not going to place these two grid lines on those places, but we are putting this because of this lift wall. Why this is here? Because of the column. Okay, that is fine. So in that course now, I'll then type what? XL enter, H, enter, and I'll come here, click on this, and then trim. Make a trim to have all the grid lines to stop at the same point. That is fine. And I'll delete this off. Again, XL, enter, V, enter, and I'll click on this here. Click on this, TR to trim this off. Okay, that is fine. And then this off, that's fine. And again, XL, enter, H, enter, come here, take my reference point from this point, click on this, TR to trim this off like this, and then this goes, that is fine. And then again, here again, XL, enter, V, enter for vertical, click on this point here, hold this point, TR to trim, and then trim this off, that's fine. So this goes now and this goes, that's fine. So with this now, we are now done with the grid line stage. Let's now move to the part 2 of this course video, which is now the column placement. And remember I told you guys that we are going to use just 12 columns to carry this 6-story building hotel, 6-story hotel building, sorry. And we are going to be using a minimum size of 400 by 400. That's because of the amount of load going to each of the column based on the beam spans 77 meters and above. So with that, now let's now move into the column positioning stage. But before then, let me just move this plan upward a bit around here so that you can be seeing both the elevation and the column point that we are going to be using. So let's now go to the part 2 of this course video.